Good morning, team. We are going to look at the next section in math today. We're looking at lesson 1.2. We just finished 1.1 last week. Today we are on pages 12 and 13. So on page 12, we're going to do 1 through 3, and page 13, we're going to do pages 4 through 6. This is building on some of the skills we've already been doing. And so I'm going to walk through some of those on a document camera and show them here. So if you haven't done this before, or if it feels a little new or confusing, please make use of the like pause and rewind and listen to how I'm solving it. And you only have to do the 3 problems on each page to get warmed up. And then starting tomorrow, we're going to do a longer assignment based on these. So please make use of stopping and re-listening to the directions as you're going through. And I hope that this helps you get started. All right, so we are going to start right here in solving a 2-step equation. The question that we're reading is the height in feet of a tree after X years. And if you remember, X is going to be our variable that we're going to be searching for, is 1.5x, so 1.5 times x plus 15. After how many years is this tree 24 feet tall? So I'm going to switch over to writing it myself, and then we're going to do it together. Okay, so we have our equation written down, and again, we're going to be looking to find the how many years it'll take for the tree to get to be 24 feet tall. So in our equation, x is going to be the number of years. Okay, and so then we're going to be able to find out the answer in feet. There we go. So x is our number of years. We're trying to find out how many years it'll take for the tree to be 24 feet tall. And we've been given this equation. So the first thing that we're going to do, if you remember, is we're going to try and isolate for this x. Okay, and this is the same thing we were doing last year. So not last year, last week. So if you remember, when we isolate for a variable, we want to get that variable all alone. So isolation means to get it all alone, and then we'll find out what it actually equals. So in order to do that, we're going to do the inverse operations, and we're going to try and move any of the numbers over here over to this side of the equal sign. Okay, so the first thing that we're going to do is undo the addition, meaning we're going to do the inverse operation of the addition, because that's the easiest thing for us to get rid of over here. Oops, made a little blurry. The multiplication is going to be trickier, so let's just go ahead and get this addition out of the way. So the inverse operation of the addition is subtraction, and that'll help us get rid of that 15 over on this side of the equal sign. Since we did it here, we have to do it over here too. So we're going to subtract 15, we're going to turn that into a 5. Subtract 15 from 24, and we are going to have 9. Okay, so we haven't done anything to the 1.5x, so we still have 1.5x equals 9. Okay, so we've gotten rid of the 15, we've done the inverse operation and then done the same operation on the other side. So now we have 1.5x, and if you remember, when you have a number right before a variable, it always means that we're multiplying. And so the inverse operation of multiplication is division. So we're going to multiply, or not, sorry, we're going to divide 1.5x by 1.5. And that's going to help us cancel out the 1.5. And then we still only have x over here. Now we've done our job. We've gotten rid of everything that has to do with x. We've isolated x. The last thing we have to do is make sure we do the same operation on this side of the equal sign that we did over here. So we're going to divide 9 by 1.5. And the answer that we will get is 6. So we've done all the inverse operations to isolate for our variable. Our variable is the number of years. And so the final answer is that it will be 24 feet tall after 6 years. I'm just going to get set up and do the next equation. The next equation we're going to do, we just finished this one, and all the steps are also written in your book, all the steps that I just went through with you. The next portion is combining like terms to solve an equation. And so I'm going to write this on my whiteboard and we'll walk through it together. I'm just going to scooch this over. I'm actually going to zoom out a sprinkle so you can see more of what I'm doing. Hopefully it will refocus and not be blurry. So when we combine like terms, so the equation that they give us that we're looking here, oops, hopefully that will focus for us. The example they're giving us here is example 2, solve 8x minus 6x minus 25 equals negative 35. So we're solving to find out what x is. So first we're going to write out our equation. 8x minus 6x minus 25 equals negative 35. Now, before we were just trying to isolate for x, but now we have some terms that we can combine first in order to make it easier for us to solve. So when we do that, first, we're going to combine the things that are similar. Now, we can only combine like terms on one side of the equal sign. So we can, anything over here that is a like term, we can combine. And if this was a more complex equation on this side, we could combine things over here, but there's only one number. So we just leave this one the way it is. The way we combine terms on this side is that we look at any of the numbers that are set up similarly, meaning these two are both numbers multiplied by x. So these are like terms. We could actually put those together. And when we are combining like terms like this, I like to think of the numbers as only with when we have addition and subtraction, we can think of those numbers as kind of connected to the sign in front of them. So we've been doing a lot of work with positive and negative integers. So we can actually think of this as a negative 6x and a positive 8x. So these are both numbers times x. This one is a negative, this one is a positive. So we can take our knowledge of the number line and positive and negative integers, and we are going to just combine 8 and negative 6. It's just as simple as combining those two, meaning adding those two. So if we combine 8 and negative 6, we're going to be left with 2, and it has our variable x. So we're going to keep x. So we've combined these two because they're alike and gotten them into 2x to make it more simple for us. This is just an integer on its own, so we can't really combine that with anyone else to make it easier to solve, so we're going to leave it. It still is negative 25 or minus 25 equals negative 35. Now we have a very similar equation to what we just saw before. We're going to go through doing the same exact strategy to isolate to get this x all by itself. First, we have to get rid of all the other numbers. So first, we're going to get rid of the ones that aren't attached to the x because that's easier. We have this negative 25 or minus 25. So we're going to do the opposite of that to cancel it out. The inverse operation of minus is addition, or the inverse operation of subtraction is addition. So we're going to add 25 so we can totally cancel it out on this side. But since we did it over here on this side of the equal sign, we have to also do it over here. So we're going to add 25 to our negative 35. So negative 35 plus 25 is negative 10. So we've gotten rid of the 25 over here. So we're still left with our 2x. We've got 2x equals negative 10. Our next step is to do the inverse operation of the multiplication that's happening here. So we're going to divide by 2. That cancels the 2 out on this side. So we can get all the way down to just the x all by itself. Remember, we isolated it. We want that x all alone. I'm not going to leave those there because that would be more complex, but I wanted to draw attention to that. So we have our x. We've divided 2x by 2 to cancel the 2 out over here. Since we did it on this side of the equal sign, we got to do it over here too. So we're dividing -10 by 2, and -10 divided by 2 is -5. So in this operation, we did the exact same thing we've been doing, but before we started, we tried to make it more simple by combining like terms. That's the new skill that we're looking at right here. So now your job is to pause the video and you're going to go and do page 12, numbers 1 through 3. Just like I just ran through, pause the video, do those, and then come back and I will teach the next page. Just pause and come right back. All right, team, you guys should have just finished page 12 and done those 3 practice on your own problems on the bottom. We're now going to move on to page 13, and we're going to look at example 3 first, then we'll go on and look at example 4, and you'll have 3 more problems to do on your own. So first, what we're going to do is look at page 3. Let me flip my camera over so you guys can see my book. And we're looking at page 13, example 3. So we're adding another skill into our tool belt. On the previous pages, we practiced isolating for a variable by doing the inverse operations. And then doing the exact same thing, we practiced combining like terms. And the next tool that we need to solve equations like this is using the distributive property. We've talked about this a little bit already with some of you. I think we've looked at it on IXL a little bit, but I'm going to go ahead and walk through this one that's in your book. If it's easier for you to look through the book, that's fine. I'm going to write it out so I can talk through how I would do it. Let me just move this over. Okay. So we have on the top of page 13, number 3, the equation is to solve 2 times 1 minus 5x plus 4 equals -8. So we know that to solve, we're going to be trying to find this variable. We're still doing the exact same methods. We're just adding the distributive property into this toolbox that we have when we're doing algebraic equations. So we've written the equation out. And when we do the distributive property has to do with how we manage this situation with the parentheses. If you remember, because of our order of operations, we have to manage these parentheses first. Parentheses are the first thing we have to look at. So in order to start isolating this variable, we need to get it out of the parentheses so we can do the math we've been doing so far. And the way we get it out of the parentheses is to use the distributive property. So with the distributive property, we multiply this number outside the parentheses. This works because we're multiplying 2 by what's in the parentheses because there's no sign or space in between the 2 and the parentheses. This would be the same thing as writing 2x, 2 times x. We know that that means it's being multiplied, is what I'm saying. So the distributive property means we distribute the multiplication across the 2 or 3 or however many pieces are in the parentheses. So we're going to multiply 2 times 1, and then we're going to multiply 2 times -5x. We're going to keep that negative because it's going to be a subtraction. So the first thing we're going to do is multiply 2 times 1, which is going to give us 2. That one we can all do in our head. And then we're going to multiply 2 times -5x. Now I'm going to pause right here because in the book, it's going to write it out even a little more specifically. I just want to show you so that in case you're looking at the book, you don't get confused. Right here in the book, they have the 2 times 1 minus 5x. So you would still do that 2 times 1 and then 2 times 5x, but they've actually written it out fully like this and just kept the minus sign in between. The way I'm telling you to do it with a 2 times -5 is just a little bit faster. But if this makes more sense to you when you look at the equation and you're looking at the book, you can write it fully out this way also. So you could write out, okay, 2 times 1 minus 2 times 5x, okay? 2 different methods of kind of getting to the same answer or the same method. So when you look at the book, it will look a little differently than what I'm doing. Feel free to pause and go back to how I described it or look at the way the book does it. Either way is totally fine. There's between those 2 methods, not a wrong way. Okay, so when I'm doing it, I'm going 2 times 1 in my mind because I drew the little lines. That's how I keep track. 2 times 1 is 2. 2 times -5 is -10. So still minus 10x. The x stays with the 5. So now we've gotten rid of the parentheses and we still have the plus 4 equals -8. Now we're going to think back to example 2 where we combined like terms. And we're going to say, okay, well, on this side of the equal sign, what could be combined? Well, we can't do anything with the 10x because none of the other numbers are multiplied by x. So 10x is going to stay the same. And if we think about it in terms of, like I said before, like these chunks stay with the sign in front of them when you're doing negatives and positives, or sorry, addition and subtraction. So we're going to keep the negative 10x together, but because there's a minus sign, we have to make sure it stays negative. So that's an important step you could miss. The other 2 things we can combine are the 2 here at the beginning and the 4. And we know that the 4 is a positive 4. So we have 2 plus 4 is our positive 6. So 10x, negative 10x plus 6 equals, we haven't done anything over here yet. We haven't even worried about this side of the equation of the equal sign yet. So our -8 stays the same. So we're whittling down to get to this skill that we already know how to do. We are using our new skill of the distributive property, and then we're combining like terms like we did in example 2. And now we're able to just do our inverse operations and isolate to get x all alone. We want that variable all by themselves. So we're going to get rid of the 6 first. It's the easiest. The inverse operation of addition is subtraction. So -6 to cancel those out. We did it on this side of the equal sign, so we have to do it over here. So -8 minus 6. I'm going to keep our equal sign. -8 minus 6 is -14. And then we haven't done anything to our -10x, so that's going to stay the same. But now we can do our inverse operation of multiplication of -10 times x. So we can get rid of our -10 and get that x all alone by doing the inverse operation. So we're dividing by -10. That will cancel out our 10 over here. We've got our x all alone. And then the -10 that we divided by over here, we have to mirror over here. So we're dividing by -10. And -14 divided by -10 is 1.4. So as you can see, we're just slowly building on the type of math that we've been doing so far. Okay, now I'm looking at the book. I'm not going to write out the example here in number 4. I'm just going to talk through it really quick because this is just an example where you could apply this type of math to real life. So in this example number 4, which you don't have to write out, the example is giving you this problem to use a table to find the number of miles, which is designated by the variable x, that you need to run on Friday so that the mean number of miles, average is mean. We're just trying to do an equation to find out the average number of miles run per day is 1.5. Okay, so we need to figure out what number to plug in here for the average amount of miles to be 1.5. I might make a couple notes on this because we actually haven't done one like this with the division. So let's, or since at least today we haven't, we did it last week. So I will actually talk through this really quick. So let me grab my pencil so that I can actually write on stuff. So we haven't actually done anything with a mean before, or an average. Mean is the same thing as an average. So before we start this, let's remember that when we average something, we add them all up, and then we divide by the total number of things we added. So we're going to add 2 plus 0 plus 1.5 plus 0 plus mystery number x. And we're going to divide that by 5 to get our mean, to get our average. Okay, so the setup of this equation here is based on the idea that you would know that to get the average, you have to do that first. Okay, so without understanding that, you wouldn't necessarily to be able to understand why they set it up this way. So what they're doing here, let me get a sticky note. Okay, what they're doing here is they're taking all these numbers over here, like I just said, 2 plus 0 plus 1.5 plus 0 plus x, and then dividing it by 5 because there's 1, 2, 3, 4, 5 numbers, 5 days. And then they want their average number of miles ran to equal 1.5. So they want to figure out how many miles they have to run to make sure they average 1.5 miles a day. So they've added the numbers and divided it by 5. That's how they got this original equation set up. Okay, so if you're looking at your book, I'm hoping that that wasn't confusing to start out with, but hopefully that was clarifying. So the next step they're going to do here is to combine their like terms. So all of these numbers up here can be combined because they're all just positive integers that can be added together. So we've simplified it to 3.5 plus x over 5 equals 1.5. So the combining like terms, you can do that there. The next step is to get rid of the 5 underneath, because we can't do anything with this 3.5 while it's still being divided. So in the words of the book, they'll say undo the division, which is the same idea as doing the inverse operation. So if it's easier in your brain to think about undoing an action than it is to just say inverse operation, think about it that way. So they're undoing the division, so it's being divided by 5. So instead of dividing by 5, they're multiplying by 5. Since they did that on this side, they have to do the same thing over here. So they multiplied 1.5 times 5 after they canceled out the 5 on this side. Once they've canceled out the 5 on this side, they've got it down to 3.5 plus x equals 7.5. And that's something, now we're down to something that's kind of simple, like we started in the very first day we started doing this, we had questions like this. All we have to do here is subtract this positive number because 3.5 is positive. So we have to do the inverse of a positive to get rid of it. We're subtracting it. We subtract it from both sides and we get x equals 4. So they would have had to run 4 miles on Friday to get the average that they wanted. Okay. So what you are all going to do is questions, if I can get to it. Hang on, my camera's being a little strange. There we go. You guys are going to go through and do page 13, numbers 4 through 6. And these two, you're going to be doing your distributive property here. Remember, 3 times x plus, or sorry, negative 3 times x plus negative 3 times 2. You're going to combine your like terms and simplify, isolate for your x's. And then you're going to do the same thing over here. You're going to do your distributive property first. Always manage your parentheses first. Remember, PEMDAS parentheses are always the first thing. And then you're going to combine like terms, and then you're going to start subtracting things to get rid of them. Okay. So those two are going to be the complex versions of what we've been doing using all the tools in your toolbox. Number 6 is going to be a question just like this one. So you scored 88, 92, 87 on 3 tests. Write and solve an equation to find the score you need on the 4th test so that your mean test score is 90. So you're going to set this up just like we did up here, with all those test scores are going to be on the top, and you're going to plus X, because you're trying to find the mystery test score. And you're gonna divide that by 4, because there's 4 tests, and it's going to equal 90, because your average or your mean is needing to equal 90. So that's the end of your assignment for today. And once you finish that, take a picture of your work and submit it to me. In your work, you need to have page 12. Sorry, this is the teacher book, so there's extra pages. Page 12. Oh, that's blurry, so sorry. Page 12, 1 through 3, and page 13, 4 through 6. I'm gonna write that down. Page 12, number 1 through 3, and page 13, numbers 4 through 6. Good luck. Let me know if you need any help. Feel free to pause and go back in the video as much as you need.